Hello everyone, this is just an extra video designed to help understand better kinematics. What we're going to do in this video is derive all four of the kinematics equations we talked about in the kinematics and vectors review. So we're going to derive them using these three equations. The acceleration equation, which I substituted delta v for the actual vf minus v naught. Then the velocity equation. Then this new equation you might see here is average velocity, the definition of average velocity. All right, so, and this is the definition of average velocity, v naught initial plus v final divided by 2. That's just how you find an average. So the first equation we can derive is this one. So we're going to write this equation right over here. 1. Hey, so we're going to multiply each side by delta t. So we're left with vf minus v naught. There's a delta t. Then we have vf equals v naught plus a delta t, and that is the first equation we've done in the presentation. Now we'll work on deriving the second equation. So the second equation we'll derive using the velocity equation and the definition of average velocity. Now, during the case of acceleration, the average velocity will also be equal to delta x or delta time. That will be the average. That is the definition of this second formula, average velocity. So we can just set those two equal to each other. So that's v, start with that, just to stick in your mind that they're equal to each other. Sorry. Okay, so we're going to set each of them equal to each other. Delta x or delta t equals v naught plus vf divided by 2. All right. Now we're just going to have to multiply by delta t to isolate delta x equals delta t times v naught plus vf divided by 2 and some people like to write it as 1/2 times delta t plus v naught plus vf. So this is basically the second equation in two different forms. This is the second equation. The third equation is basically a plug-in to the second equation. So the second equation is, we'll just write the second equation, 1/2 that times delta t times v naught plus vf. All right. Now what we're going to do here, okay, so what we're going to do here is we're going to take this first equation and we're going to substitute it in here, right here, because that is equal to vf. Okay, so what we're going to do, erase that other delta I just put there. So we're going to just put delta x equals 1/2 delta t times v naught. Then we're going to substitute the first equation in, plus v naught plus a delta t. All right. that equals delta x equals 1/2 delta t times v naught plus v naught is 2 v naught plus a delta t. All right, so we're just going to distribute the half delta t. So that equals, well, 1/2 times 2, that'll just equal 1, plus delta t times v naught, or v naught delta t. Then 1/2 times delta t plus acceleration, a times delta t. So delta t times delta t is delta t squared. So that's 1/2 times a times delta t squared. So that is our third equation. So what we're going to do, is, this is our third equation. Now the fourth one is a little more complicated. Okay, so the fourth equation, deriving that, is a little more complicated, just a little more algebra. So what if we multiply the acceleration times the displacement? Okay, so what do we get? Now, for acceleration, we're just going to put the acceleration equation. So that's v naught vf minus v naught divided by delta t. And then for this, for delta x, we're going to put in the the second equation. The second equation, 1/2 delta t times v f plus vo. Okay, so you might see these delta t's will cancel. So we're left with a times delta x will equal 1/2 times vf minus vo times vf plus vo, right? We're going to multiply each side by 2 so we can get rid of that 1/2. So I have 2a delta x equals vf plus vo times vf minus vo. I just switched the order. Okay, now if you remember from algebra class, this should be familiar. It's the difference of two squares. A plus b, a minus b equals a squared minus b squared. So that's vf squared minus vo squared. And if we add vo squared to each side, we have vf squared equals vo squared plus 2a delta x. Okay, and that is the fourth and final equation. So we basically derive all four equations by using the top three equations at first, and then using the other equations to our advantage to successfully derive all the equations. And we're done. Thank you. I hope this led you to a better understanding about how these equations work. And I hope you enjoy about how beautiful math is and how it all connects together.